hydrogen spectrum is a which is a emission spectrum, emission line spectrum. How this hydrogen emission line spectrum is going to be formed? Suppose I am taking that there is a hydrogen gas is taken here. So this hydrogen gas, whenever it is maintained under the low pressure condition and some electric discharge or some light is passing onto the hydrogen gas, whenever some light is passing onto this particular hydrogen gas, this hydrogen gas is present at a very low pressure condition and it will absorb some light and it will goes to the high energy state. In that high energy state and which is going to be highly unstable one, and immediately it will emit the some light. So that light, whatever the emitted light, this emitted light is going to be passing onto the nickel prism, right? So whatever the light emitted from the hydrogen gas, this emitted light, if you are passing onto the nickel prism, and if it is passing onto the nickel prism, the spectrum obtained here, the spectrum which is obtained here, that spectrum is called as a, here the spectrum is nothing but it's a full of different lines are there. The spectrum which is obtained here, that we can call it as a, it's a nickel, it's a hydrogen spectrum. So this emitted light, if it is passing under the nickel prism, whatever the spectrum is obtained, that spectrum is called as a, it's a hydrogen emission spectrum. Why it is called as a emission spectrum means because it is recorded from the emitted light, right? So this hydrogen emission spectrum, actually it is the smallest, the atomic shortest atomic spectrum, or the smallest atomic spectrum we can say, right? So in this hydrogen spectrum, actually in the hydrogen it is having the only one electron, but when we are recording the spectrum, there is an n number of spectral lines are obtained. Why? Because in the atomic structure, atomic number of hydrogen is only one, so that most of the people generally will expect that only one spectral line should be obtained. But when we are recording the spectra, we have there is an n number of spectral lines are obtained here, right? So for this n number of spectral lines are further studied by the different scientists are analyzed this spectrum, and the first scientist who analyzed this hydrogen spectrum is Balmer is a scientist. Here Balmer is one scientist. He has analyzed this particular hydrogen emission spectrum, and he has found that some of the spectral lines are absorbed in the visible range of radiation. In the visible range of radiation, we have that in the electromagnetic spectrum or electromagnetic spectrum. There is an it is composed of different kind of electromagnetic radiations are there. These all the electromagnetic radiations. So in that visible is the one that only we can able to see from our naked eye, which is having the different colors. In the Balmer is a scientist, actually he has found that in the particularly this hydrogen emission spectrum, and he has found mainly there is four spectral lines are particularly found in the visible range of radiation with the four different colors. What are that four spectral lines? I am taking that this is an H alpha line is a one, and other one is a H beta line is another one, and other one is there is an H gamma line is another one, and other one is there is an H delta line is another one. This H alpha line, which is in the range of particularly there is an 6563 angstroms, and it is appeared in the red color, right? So whereas this particular one is 4801 angstroms, this is an which is there in the particularly green color, and other one is there is an 4340 angstroms. That means this H alpha line is found in the range of wavelength, this is in a 4340 angstroms, and it is there in the blue color region. And other one is H delta line. This H delta line is found in the 410 angstrom, which is there in the, so there is a violet color, right? Balmer is a scientist. Actually, he has found that mainly 4 spectral lines in the visible range of radiation, and that 4 spectral lines are given as a notation as a H alpha, H beta, H gamma, and H delta. And here this H alpha line is in the 6.63 wavelength of 6.63 angstroms, and in the red color it is appeared with the red color, whereas in H beta line is at a 4801 angstrom, and it is appeared with the green color, whereas in H delta line is with the 4340 angstrom, and which is appeared with the blue color, whereas the other one is a H delta line, and which is a 4101 angstrom, and which is appeared with the violet color. Now later, after the discovery of these 4 spectral lines, this whatever the 4 spectral lines are there, these all the series of lines are called as it's a Balmer series. Later, after the Balmer, there is an Lyman is another scientist. He has found that there is some of the spectral lines is found in the visible or UV range of radiation. In the UV range of radiation, he has found some spectral lines that we can call it as it's a Lyman series, right? Later, there is a Fashion is another scientist. This Fashion is another scientist. He has found some of the spectral lines. These all are what they have done analyzing the hydrogen emission spectrum. They have found that different spectral lines in the different range of radiation and the different range of that electromagnetic spectrum. This Fashion is found again near infrared region, near IR region. He has found some spectral lines. That spectral lines are called as a Fashion series. And later there is a Brackett is another scientist. This Brackett also, he has found some of the spectral lines in the middle IR region, middle infrared region, middle infrared region. He has found some of the spectral lines. That spectral lines are called as it's a Brackett series. Whereas the other one is there is a Fund is another scientist. He has found some of the spectral lines in the far IR region, far infrared region, and that spectral lines are called as it's a Fund series. And other one is there is an Humphrey series. Humphrey series. Humphrey is a scientist. Actually, he has found some of the spectral lines. Not only this Fund, even Humphrey is also found in the same far infrared region only. He has found some other spectral lines. That spectral lines are called as it's a Humphrey series, right? But actually, the first who discovered or who analyzed this hydrogen emission spectrum means Balmer is analyzed. He has found a series of lines. That series of lines is called as a Balmer series. Later Lyman, and then later this Fashion, Brackett, and Fund and Humphrey series are discovered, right? So for this all the different kind of series of lines, and we can find out it's a wavelength, and its a wave number can be calculated by using its a Rydberg equation. That Rydberg equation is a wave number nu bar is equals to 1 by lambda into this is an RH. 1 by lambda is equals to RH into this is a 1 by n1 square minus 1 by n2 square. So this is a equation will helpful to find out it's a wave number and a wavelength of different spectral lines. This equation is generally known as it's a Rydberg equation, and a nu bar is a here wave number, lambda is a wavelength, RH is a Rydberg constant, whereas N1 is a lower energy level and N2 is a higher energy level, right? Always here we can able to find that there is an N2 value is always greater than the N1 value, right? So this equation can be applied for all the these 6 types of series of lines. Generally for the Lyman series we have that N1 value is 1 and N2 value is it will start from the 2 comma 3 comma 4 and so on up to infinity will write. Lyman series N1 value is 1, N2 value it will start from the 2 3 and so on up to infinity we can write. Whereas for the Balmer series generally we can call it as this is the first one, but actually as for the notation point of view, discovery point of view, Balmer is the first analyzed and he discovered that, later Lyman. So but when we are coming for the Rydberg equation and N1 N2 values point of view, so Lyman N1 equals to 1 and its N2 values are 2 3 4 and up to infinity will write. What about in the case of the second Balmer series is here N1 values are 2 and N2 values are, it will start from the 3 comma 4 and so on up to the. So for the Balmer series N1 equals to 2, N2 is equals to 3 comma 4 and so on up to infinity will write. Whereas in the case of next third one is this is a fashion series. In this fashion series there is an N1 value will write on the 3 and N2 is equals to will write on the 4 comma 5 and so on up to infinity. That means here N1 is for this one 1, N1 is here 2 and then N1 is here 3 and for bracket series fourth one is bracket series N1 is equals to 4 and here N2 is equals to 5 comma 6 and so on up to infinity will write, right? And the next fifth one is a fund series. Here N1 is equals to and 5 and here N2 is equals to will write on the 6 comma 7 and so on up to and infinity will write. And the next sixth one is a Humphrey series. For this Humphrey series N1 is equals to 6 and N2 is equals to will write this is a 7 comma 8 and so on up to infinity. Why I am writing that infinity means this infinity is the last one. From that if any electron excitation takes place or any de-excitation takes place, so whatever the spectral line obtained, that spectral line wavelength is called as it's a limiting wavelength. I am using the another word here. So limiting wavelength, limiting wavelength. What is mean by this limiting wavelength? Limiting wavelength is nothing but if N1 value is you can take any one like 1 2 3 from for 1 or 2 or 3 or 4 or 5 or 6 you can take any one. But if N2 value is in the Rydberg equation, if N2 value is infinity is there, from this infinity to any one like a 1 comma 2 comma 3 and so on up to n. So any electron excitation, de-excitation takes place. That de-excitation will give rise to the some spectral line. This spectral line wavelength is called as it's a limiting wavelength, right? We'll use the word, some specific word. They will ask so many problems based on this limiting wavelength also. What is the limiting wavelength? If you are in the Rydberg equation, if N2 value is infinity and N1 is 1 2 3 and so on up to n will write the spectral line obtained due to the de-excitation of electron. Such a spectral line wavelength is it's a limiting wavelength, right? So whatever the different kind of spectral lines are obtained, that all the spectral lines wavelength can be calculated by using its Rydberg equation. This equation is a generally Rydberg equation, and here RH is a Rydberg constant. It's a Rydberg constant value. I am writing here RH is a Rydberg constant and its value is a constant. We will write 109677 centimeter inverse. Or you can write this is in a 1.09677 into, we will write this is a 10 power 7. This is in a meter inverse.